Hello everyone, today we'll be doing Maths Paper 1, Higher Tier, GCSE 2022 at Excel, and yeah, let's get straight into it. But before you do, if you know anyone that needs help with this exam, please send them this video. And also make sure, okay, so another thing is that this test is very hard, and that's for the increasing difficulty in the last problems and the last problem. The last problem I would say is probably the hardest one that has ever been done in maths. I don't think there's been as hard of a problem as before. So yeah, let's begin. Question 1. Solve 7x minus 27 is less than 8. So the way I think about this, if you're just trying to find a cool method, this can be replaced with an equal sign. So we'd have 7x minus 27 is equal to 8. Then we can just solve for x. So 7x equals 35, and then divided by 7, x equals 5. Now remember, because we had this, we have to replace it. So if we replace the equal sign with the original inequality sign, you get our answer. An important note, if you ever multiply or divide by a negative, you always flip it. So if you multiply or divide by negative twice, it's still the same, and so on. If you multiply it 3 times, it'd be flipped, but yeah. Next, write 124 as a product of its prime factors. So the way we can do this is by drawing out a factor tree. So we can write 124 here. And now in the exam, if I'm seeing 124, I probably can't think of its perfect factors that can go into it. All I know is I can see a 2. And what happens when you divide by 2? You get 62. Now with factor trees, every time you see a prime number, you want to circle it. Okay, now I have 62. Once again, I can see a 2. And I see a 31. 31 is a prime number, so we can circle it. Now we have our prime factors, so we can write out our answer. So it's just 2 times 2 times 31, and if you multiply these, you'll get 124. Alternatively, you can write that as 2 squared times 31, but the mark scheme does say 2 times 2 times 31. Both methods, by the way, are valid. Write it however you want. If it's a long number, you might want to write it in a more compact form. Question 3. A delivery company has a total of 160 cars and vans. The number of cars to vans is 3 to 7. And each car and van uses electricity, diesel, or petrol. 1/8 of the cars use electricity, 25% of the cars use diesel, and the rest use petrol. Work out the number of cars that use petrol. Okay, so it's going to be kind of like a cut off one-way table, if that makes sense. So we have cars. I'm going to put electric. I'm going to put diesel, petrol, and total. Notice we can abstract this problem and realize that we do not care about vans. There's no implication with vans, there's no relation between cars and vans other than the ratio. Let's find the total, okay? How can we find the total? Well, we have 160 cars and vans, and the ratio is 3 to 7. So we have 3x plus 7x. Now, I call it x because it's like a multiplier. Ratios keep proportion, and the x just tells you the multiplier with some math. Anyway, it doesn't matter. 160. You may call these units, it's just the same thing. So that might be a relation when you're doing these ratio problems. But you want to add up all the parts and just say call them x or something to get some total. And you get 10x equals 160. So the multiplier in this case is x equals 16. Okay, so now we can multiply 3 times 16 is equal to 48. Okay. And that would be 48 cars. And now we can put total cars equals 48. Going back to the question, 1/8 of the cars use electricity. So if we just write electric, 1/8 times 48 is just 48 divided by 8, which is 6. So 6 cars is electric. 25% of the cars use diesel. Diesel is equal to 1/4, which is 25% as a fraction, times by 48. That's 48 divided by 4, which is 12. So now we can figure out this last one. Petrol is equal to 48 minus 6 minus 12, which is equal to 48 minus 18, which is equal to 30. That is our answer. Question 4. A. Write 1.63 times 10 to the minus 3 as an ordinary number. Let me show you how to do this. So we have, if I zoom in, it might help. We have this -3 over here. So what does this -3 mean? Well, if it's a -3, we're going to write 3 zeros. Then afterwards, write out the number here. Don't add any decimal, just write out the number. So write out the digits 163. And afterwards, just add a decimal after the first 0, and that will be your answer. Why does this work? Well, let's do it. So times by 10 to the -1 means just divide by 10. So if we divide by 10 once, we get, twice we get, and 3 times we get this. Oh, sorry, actually, sorry. There you go. Okay, answer. Next, write 438,000 in standard form. So here's how we do it. So write out all digits from the first non-zero digit to the last non-zero digit. So if there was like a 7 instead of here, we'd write 43807. Okay, so just there. Add a dot, a decimal point after the first digit, and then times by the number of digits after the first one. So we have 1, 2, 3, 4, 5. So times 10 to the 5, and that'll be your answer. Next, work out 4 times 10 cubed times 6 times 10 to the -5. Now, if you may have not been taught this in primary school, but multiplication is commutative. What this means is we can swap around the numbers and we'd still get the same answer. So 4 times 6 is equal to 6 times 4. That makes sense. But 4 minus 6 is not equal to 6 minus 4. You see, subtraction doesn't work like that, but multiplication does. Okay? So let's rearrange these by putting the non-10 powers to one side and the 10 powers to one side. So we'd have 4 times 6 is 24, and then you should have 10 cubed times 10 to the -5. Okay? Now we can evaluate this much easier. So you have 4 times 6, which you can simplify down to 24. And we have 10 cubed times 10 to the -5. Notice how the bases are the same. So when we multiply, we add the powers. So 3 plus -5 will give you 10 to the -2. However, this is not in the standard form because you have 24, okay? The number has to be less than 10. So let's write this as 2.4 times 10, right? We just divide by 10. And this division by 10 just makes 2.4 times 10. And you have 10 times 10 to the -2 times 10 to the -2. Once again, we have this little addition here, and this is technically 10 to the power 1, but we don't show it. So when we add 1 plus -2, we get -1. So this will give us 2.4 times 10 to the -1. Is our answer? Okay, nice. Let's move on. Here's a regular hexagon and a regular pentagon. Work out the size of angle, mark the X. Okay, so notice that this is a point, and there's an angle here and an angle there. And you know, angles around a point add up to 360. Okay, so in order to find X, you need to subtract one angle of a regular hexagon and one angle of a regular pentagon. Okay, so let's figure out how we can do this. So if you want to figure out the total interior angles, I'm going to start with the pentagon. It's equal to, the formula is n minus 2 times 180. I'll give you the total. Okay, so let's do it. Let's plug this in. That gives 3 times 180, which is 540. Now that is the sum of the total angles. A pentagon has 5 angles, okay? 5 sides, so 5 angles. And because it's regular, every single side will have the same angle. Every single angle will have the same size. So imagine we call these all y, okay? And we have 5y. So once we figure out y, we just divide by 5. Hopefully that kind of makes sense. And so 540 divided by 5 is equal to 108. So this angle here is 108. Okay. Now let's do it for the hexagon as well. Hexagon, by using the formula again. 6 minus 2 times 180 equals 4 times 180, which is equal to 720. Hexagon has 6 sides, so we do 720 divided by 6, and we get 120 degrees as the answer there. Now, like I said, angles around a point add up to 360. So in order to figure out x, we have to do 360 minus 120 minus 108. Okay, so x equals 360 minus 120, minus 108. And what would this give us? Well, this will give us 240 minus 108. And this will give us 132 degrees. Before you continue, let me quickly explain this formula. So if we have a square, if you have a triangle, actually, let's start with triangles, yeah? A triangle has total angles of 180 degrees. Okay. A square has an angle, total angles of 360. Notice how it's double. But notice how a square can be split into, this is all regular shapes, by the way. A square can be split into two, or any shape really, but a square can be split into two different triangles, and when you add up two triangles, notice how it's every angle, but they add up to 360 because 180 times 2 is 360. Let's try this with a pentagon. Yeah, we can draw a pentagon here, and we can start from this point, and we can draw out a triangle. We have three triangles, hence 3 times 180 to get 540 as the total sum. The reason it's n minus 2 is because there are always 2 points you can never draw it to, because then it won't make a triangle. Okay, the two adjacent points, there must be a gap, so it's n minus 2. Okay, moving on to question number 6. Complete table for values y equals x squared minus 4x plus 1. Let's go. What this means is when you have y equals x squared minus 4x plus 1, it's a graph. We're going to draw out a curve, and that makes a positive curve like that. However, in order to figure out the value of y when x is minus 1, we just plug it in. So when it's minus 1, we'd have minus 1 squared, which is 1, and then we have minus 3 times minus 1, which is plus 3, plus 1 to get 5. For 2, we'd have 4 minus 3 times 2, which is minus 6, plus 1, and we get minus 1. For 3, we'd have 9 minus 3 times 3, which is 9, plus 1 to get 1. For 4, we'd have 16 minus 12 plus 1, which would give us 5. Important note, notice how it is symmetrical, okay? That's another cool thing. So we have 5 here. We have 5, 1, minus 1, minus 1, 1, 5. And notice how these can be plotted because coordinates have an x and y value, and over here we have respective x and y values. So let's begin. Let's start with minus 1, and we go up to here, and we plot a 5. That was a miss. When you're doing your exam, please make this accurate. Make sure it goes through the coordinate you need. Okay, so at 1, it's minus 1 over here. At 2, it's minus 1 over here. At 3, it is 1. At 4, it is 5. Now, this forms a symmetrical pattern. Now, recently, exams have allowed you to draw these straight. So I'm just gonna, can't really draw it straight like this. Okay, I'm gonna just use a curve. Okay, so we can just go here. Let me just try this again. Of course, in the exam, you want to try go through all your points possible. Okay. Okay. So now we want to figure out our answers to this question. So, because B says, or C, because we've drawn it now, okay? Things about this graph, sorry. Make sure when you draw the lines, it goes exactly to the point. So you don't want it to go like around here and then continue. Yeah, sure, it's the trajectory, but no, it has to go through that point. Okay. Second of all, we have these 2 points here. Notice they're on the same like y-axis, but you don't connect it like that. You want to give it a little curve below, nothing too like major, but just a little curve to show that it's still existing. Now this graph isn't the best. My hand-eye coordination isn't that good, but you get the point. Anyways, using an exam, it's much easier. Anyways, using a graph, find estimates for the solutions when this is 0. So let's go back to the top. Notice it says y equals this. Notice we have this again. So we're looking for solutions when y equals 0. So when we have y equals 0, it's anything along this x-axis. And we have a point here and a point there. This, I would say, I would call it 0.4, and this I would call it 2.6, so 0.4, 2.6. And the mark scheme allows you from 0.3 to 0.5 and 2.5 to 2.7, okay? Moving on. Here are two cubes A and B. Cube A has a mass of 81 grams. Cube B has a mass of 128 grams. Work out the density of cube A to B. Give your answer to form A to B, where A and B are integers. So guys, if you get a decimal, you know you're cooked. Let's begin. How do I approach these questions with density and multiple properties? I draw a table. You might have taught this method, but I draw a table. So just draw a table here. Density, mass, and then volume, and then A and B. So we're given the masses, so we can just write them down. Let's figure out the volume. Now they're cubes, okay? So imagine you have like the little square base of that cube, and you're just adding 3 centimeters of that. So it'd be 3 times 3, and then another 3, so that'd be 3 cubed. So the volume of A is equal to 3 cubed, which is equal to 27. And the volume of B is respectively 4 cubed, which is equal to 64. So we can write these in at the bottom here. Okay, now I can figure out density. So density is equal to mass over volume. Okay, that's just the Greek symbol for it, in case you're wondering, I think. Anyways, let's figure them out. So 81 divided by 27. So the density A and you have density of B. Hopefully you understand this upgrade. You kind of obvious. Density of A, density of B, that's equal to 81 over 27, which is equal to 3 grams centimeters squared. And we just have 128 over 64, which is equal to 2 grams per centimeters squared. So we have 3, 2. And that gives us a ratio because from density of A to B, 3 to 2. There you go. So with these questions, if you have multiple parts and they have density, mass, volume, pressure, force, or area, speed, distance, or time, please draw out a little table like this and just start filling things in with what you know and any formulas you're given. Question number 10. The table shows the amount of snow in centimeters that fell each day for 30 days. Now we have an amount of snow and frequencies, and this is a table with a range grouped. So how can we do this? So I'm actually gonna extend this table out here. So I'm gonna extend it out here. I'll show you how to do it. I'm just gonna draw that top there. There. Okay. I'm gonna call this a total. And then we have there. Just drawing this across. You'll see. So you kind of want to draw a table like this, though. I mean, I'll show you how you do it first. You can do it below, obviously, but this is a really good way to just keep your working clear to the examiner. So first we're going to find the midpoint. Now this is to be the midpoint of the amount of snow for each group, and then we'll have m times f, which is the midpoint times frequency. So we know the total, by the way, for the frequencies is 30 because it's just 30 days. So here's what we do. Now the mean, so if you have 8 values between these, we don't know what they are. However, we can take an average and just say they're all 5, right? That would be average because half of them theoretically will be below, half of them will be above. So then let's just make 8 of them 5, okay? So the midpoint of this group is 5, okay? And then 8 times 5 is 40. Let's find the midpoint for all the other groups. We have 15, 25, 35, and 45. Now we can do midpoint times by frequency, which we have based on the organization, we can just easily read across. So 10 times 15 would be 150. 7 times 25 is 175. 2 times 35 is 70. And 3 times 45 is 135. This gives us a total here, which we can add. So we'd have 190 plus 175, give us 290 plus 75, which would give us 365, plus 70, which gives us 435, plus 135 gives us 570. 570. Now, if you know the mean in general, the mean is the total over the total like added up minus the amount divided by the amount of values you have. So the mean is equal to 570 over 30, which is equal to 57 over 3, 19. Just to prove you can do this here, and give a 1 to 19. Get your answer there. Next question. This question looks to be confusing. It's a 3 marker, and honestly, if I saw this in an exam, I would generally give up. If I give up, I don't mean I'm going to close the paper and just not do any more questions. By that, I mean I'm probably going to skip it. Is it hard? No. Is it long? Completely. For 3 marks, it's a bit long. And you can make mistakes on this quite easily. That's another reason why I probably skip this question, come back to it once I've warm myself up even more because you can make mistakes easily and just lose everything. So let's read this question. Hopefully not too long. A cube is placed on a cuboid as shown in the diagram to form solid. The cube has edges of length 4 centimeters. The cube has dimensions of 7 by 6 by 5 centimeters. Work out the total surface area of the solid. Now, a general definition of the surface area, which is good, is the total area you could see on the exterior of a shape. So we can't include this little bottom base because think about it, if you had an object, you would not be able to see it. So let's figure this out. First, let's figure out the bottom cuboid's surface areas. Now in the exam, you can figure them out. You can figure them out with a formula. I might figure them out with a formula, but I find that to just be too long to write. Instead, let's make our life easier and figure out the area of each side. So the bottom area is 7 times 6 because we have a rectangle, so 42. Another thing is kind of write it like parallel to the face just to make it clear, like, okay, it's this face and not to confuse with others. 5 times 6 is 30, so we have 30 over here, and we have 30 over here because it's the same side. Anyways, over here we have 7 times 5, so the 5 here is the same there. So we have 35 here and 35 at the back. Okay, let's do it for this cube now. A cube, it has sides same, so this would be 16 on the top, 16 on the side, 16 on the side, 16 there, and 16 there, and 16 there. However, we have to exclude this one because like I said, the bottom isn't shown. Okay. Next, this top one is going to be 42 because it's 6 times 7 minus 16. Okay, which is equal to 26. So let's add up all these numbers and we should get our answer. For the cube, we have 1, 2, 3, 4, 5, 16. So it's 5 times 16, which is equal to 80 centimeters. For this cuboid, let's add up these. So we have 70 plus 60 plus 42. So cuboid. We have 30 times 2 plus 35 times 2. And if you use the formula, by the way, you might go wrong. Just letting you know. Because if you don't subtract the 16, that's why you might go wrong. Otherwise, perfectly fine to use it. Plus 42. And this would equal 60 plus 70 plus 42, which would be 172. Okay. Let's go. So 80 plus 72, 172 plus 26 is equal to 252, sorry, plus 26, which is equal to 278, which is our answer. If we're thinking, oh, that wasn't that long, but yeah, I mean, if you're really not bothered to do a lot of addition, it can be, compared to others. Anyways, the table shows some information. Question 10. The table shows some information about the profit made each day at a cricket club on 100 days. So cumulative frequency, basically, you just add up, right? Cumulative comes from accumulate, which means to add up. So for each frequency, each time we go down, we add up. So let me show you. If you have 10, then we have 25, okay? Let's look at the group. It goes from 0 to 100. Now, if you go from 0 to 100, we have 10 and 15 in that range. So we have to add them all up. That's the maths reason behind it. But let's keep going. So we have 50, 80, 85, and 100. Next, we're going to plot it. So this was every 50. So let's go. So first was 10, which is halfway here. You can put that there. 10 was 25, which is kind of odd. But it's like in the middle there. 100 is 50, so, 150 is 50. So if we just plot there. And then 200 is 80. 250 is 85, and then 300 is 100. Once again, at the exams, you can just draw straight lines. I'm not going to use the ruler actually because my scroll is bad, but we can try. So you can just draw a straight line. Draw a straight line, or try your best. There you go. Then you can draw a straight line there. Draw a straight line there. Draw a straight line there. Okay. Make sure it goes through each point. As you can see, it goes through each point here, but over here is like a little gap. Make sure you go through each point. In the exam, you can really try and do this. But yeah, personally, I hate graph problems because even as smart as you are, it all comes down to how good are your hands when it comes to drawing a graph. That's literally what it comes down to. Because you may know the method and you may even understand the maths behind it, but if you can't draw accurately, you could. Use your graph. Okay, part C. Use your graph to find an estimate for the number of days on which the profit was less than £125. So how do we do this? Well, we go to £125, or we should draw where £125 is, which is in the middle of this group over here. And then we go across here. And this is 37 there because it's in the middle of 36 and 38. So this is 37. Now it says less than. If it was more than, then it'd be everything above here. So we do 100 minus 37 to get 64. Yeah, 63. In terms of the mark scheme, it was 35 to 39, in which they accept. Let's do part D. Use your graph to figure out the estimate for the interquartile range. The interquartile range is 25% of the amount, 75% of the amount minus 25% of the amount, or the upper quartile minus the lower quartile. So let's figure out where 25 is on this, which is over here. And we know that's 100. I really should be using my mouse, so I do apologize. But let's go here. So 25 there, and then 100 is there. Use ruler, please. I can't really use ruler on online software without my mouse bugging. And then let's figure out where the 75 is. So 75 is there. So if I just draw a straight line, roughly, it'll be in the same point anyways. Yeah, that's 75. I'll draw a straight line for me. That's cool. And then you go here. So it's kind of like in the middle-ish. If you draw, doesn't necessarily matter. Okay. So I'm just gonna call this 190, like 190. Just call it 190. It doesn't necessarily matter. And then you have 190 minus 100 to get 90. The range for this problem was 85 to 93. Not the best range, but hey, it's there. Question 11. Cormac has some sweets anyways. It's a ratio, lime, strawberry, orange, 9 to 4 to x. Cormac's going to take some sweets from a bag. It probably takes a lime flavored sweet is 3/7, work out the value of x. Now with ratios, whenever you have a ratio question and you're like, oh, I don't know how many I have, but here's a ratio, it doesn't matter how much they have. And unless the question is exactly asking you how much do they actually have, ignore that, okay? Because instead you can just let the, like, remember how we talked about a multiplier in the car question? Well, you could just let the multiplier be 1. So in that case, you'd have 9 lime, 4 strawberry, and x orange. So the probability takes a lime flavored is 3/7, work out the value of x. So remember, probability is the wanted over the total. The amount you want, well, that's 3/7, okay? But in terms of this question, it is 9 over the total, which is 13 plus x. Because if it has 9 lime sweets, then 13 plus x over total as well. And that's equal to 3/7. Now we can be really cheeky here. Instead of doing this cross multiplication, which is probably unnecessary, notice if we multiply this right fraction by 3, we get this. And the numerators are the same, so the denominators must be same because they are equal. So now we have this equation, and we get x equals 8, which is the correct answer. Okay. Question number 12. Express 0.1 and then 1/7 recurring as a fraction. Here's how we do it. Let r equal 0.117. Now, what we want to do is we want to keep timesing by 10 until we find 2 r values that have the same decimal point values. You see what I mean? If we have 10r, we have 1.17. We have 100r, we have 1.7, and then 1/7. As you can see, if you look at the decimals, we have not found anything that is the same yet. Let's go to 1000r. We have 117.17. Notice that the decimals for 1000r and 10r are the exact same. It's just 1/7 recurring. So now we can subtract them to get rid of the decimal. So it's 1000r minus 10r is equal to 117.17 over 1.17 recurring, and then these decimals cancel out. On this right side, we get 990r is equal to 116 And to get r, which is the fraction, it's divide by 990. R is equal to 116 over 990. There's your 3 marks in like 2 minutes. A right angle triangle is formed by the diameters of three semicircular regions A, B, C, as shown in the diagram. Show that the area of region A equals area of region B plus area of region C. This is where it starts to ramp up a bit. So I'm going to call these, I'm going to write out the radii for each one. So I'm going to call this lowercase c. I'm going to call this lowercase b. And I'm going to call this lowercase a. By the Pythagorean theorem, we immediately can figure out an expression for a in terms of c and b. So if we have 2c squared plus 2b squared, and that will be equal to 2a squared. Oh, sorry. Yeah, it would actually, yeah. So that is it, because we have to multiply each radii by 2 to get the diameter, and then apply Pythagoras. So we have 4c squared plus 4b squared equals 4a squared. To get rid of the 4, so it didn't really need it, but it's good to show you working out. Then we have a squared equals b squared plus c squared. Now, a squared equals b squared plus c squared. Okay, we're going to keep that in mind. I know that's Pythagorean theorem, but we kind of proved it there. So let's figure out the area for capital C, which I'll denote like this. That's capital C. So with capital C, the area is pi times by c squared over 2, right? Because we have the area of a triangle, the area of a circle, sorry, is pi r squared, and we have to divide it by 2 because they're semicircles. And then capital B would be pi times b squared over 2. So C plus B is equal to pi and then b squared plus c squared. Now put these in brackets because you'll be able to factorize if you work them out. And a is equal to pi a squared over 2. Going back to here, we have a squared equals b squared plus c squared. So we can just replace a squared with this. So we have pi. And then we can just write a statement saying both are equal. There you go. We have just proved that. 14. Here's the speed time graph. Work out an estimate of the gradient of the graph at t equals 2. Once again, a graph question. I really do apologize. I can't really do much about this, but I will tell you the method that will work anyways. So here is how I would draw a tangent if I was in an exam. So if you look at the ruler, I don't know if it's on the screen or not, but if you have a ruler in front of you, you notice that there are these little ticks, and I'm not talking about the longer ones, I'm talking about the really small ones. There's little ticks that like denote each like millimeter, for example. What you want to do is, it kind of works at t equals 2. You want to line them up so the tick and the line are like the same. So as you can see, it's like the same direction. So we can just draw that. And then you want, faintly, you want to draw a line there. Okay. So I can't really control that. Yeah. But so you want to draw a line, the line faintly. As you can see, it's kind of a line, so it'll work. Next, you want to rotate your ruler again, and I can't really show it to you, but then you want the little ticks to be on this, to line up with the line you've just drawn. Make sure it's faint because that's not your tangent, obviously. So the ruler needs to be placed so the ticks, I can't really rotate my ruler, I apologize for that, but you want to make sure that they are facing or going in the same direction, exactly the same direction as the line you just drew, and then you want to draw out your line again. So you just, we'll draw out your line again. We'll call that the gradient. Okay. Let me see if I can draw a better line, even though it might not be accurate. Yeah. Okay, you're gonna have to take that as the tangent. But if you had a ruler, I just told you the method, and that's how I would do it. Then you rub out the little faint line you've just drawn. Why does this work? And if it doesn't work, then my apologies, but it's still a good way to do it. Because what we're doing is we're first drawing something called a normal to the line. This is AS level stuff. We're drawing a normal to the line, and then afterwards we can draw a tangent. Normals and tangents are perpendicular to each other, and a ruler is really easy for doing this. Drawing a tangent immediately is kind of a difficult task. By drawing a normal, it makes it 10 times easier. So here is here are the 2 points I used in my paper for this. So the first one I think was 2, and then we'd have 2.8, and the second one is 0.4, 1.2. Okay, it might be on the graph somewhere, but yeah, my one would have been over here. Anyways, when you find the gradient, which I'm going to show you anyways, the gradient is it's y2 minus y1, so 2.8 minus 1.2, and then we have 2 minus 0.4 to get 1.6 over 1.6, which is equal to 1, which is the gradient. The mark scheme says 0.7 to 1.1 as the range for the gradients. Now the area under the graph, if you do physics, you should know this. It's just not the gradient. It's the distance. It's the distance. Okay. But yeah, if you get area under the graph of velocity time or speed time, it's always the distance. 15. A, B, C are 3 points such that this AB is 3A plus 4B, AC is 15A plus 20B. Prove A, B, C on line on a straight line. So let's write these in their own base vectors. So we have AB equals 3A plus 4B. We can't factorize this, okay? But notice with AC, it's equal to 5 lots of 3A plus 4B when you factorize it. And notice they have the same base vector of 3A plus 4B. So we can write 5 lots of AB is equal to AC. Okay? So 5AB equals 5AC. And both share point. So A, B are on the same line. Why did this work? Well, that's because they pass the same point, and because they have the same unit vector, that means they also have the same gradient. We're wondering, oh, if it's 5 times, surely it's steeper. When it comes to vectors, 5 times mean you just add the same length, like 5 times. That's it. So the gradient's still the same, it's just 5 times longer. Okay? DEF are 3 points on a straight line such that DE equals 3E plus 6F, and EF is minus 10.5E minus 21F. Find the ratio of the length of DF to the length of DE. Okay. So we want to find the length of DE, and we're given DE, so DE is equal to 3E plus 6F. Now I want to factorize this, so I'm going to go 3E plus 2F. And let's find DF. Notice it's not, DF is not given here. But if you want to get to DF, DF is equal to DE, because we have to go to E, and then from E we can go to F. A more visual explanation of this could be D, E, then F. We can go to E and then go to F. So let's figure out DF, which is the E plus, so it would be DE, which is 3E plus 6F minus 10.5E minus 21F, because you're adding them. Simplifying terms, we get minus 7.5E minus 15F. And we can simplify this by taking away the minus 7.5 and get E plus 2F. Now, lengths have to be positive. So we get 7.5 E plus 2F. Now, the ratio of the length of DF to DE is actually DF divided by DE. Okay, so the DF would be 7.5 E plus 2F over 3E plus 2F. Now, this cancels out to get 7.5 over 3, which we can write as 7.523. And then if you times this by 2, we get 15 to 6, and then divide by 3, we get 5 to 2. There you go. Question 16. A first aid test has 2 parts, a theory test and a practical test. Probability of passing the theory test is 0.75. Probability of passing only one of the 2 parts is 0.36. They're independent, which means that if I failed the theory test, that means it won't have any impact on the chance I pass the practical test. That's what it means. So one event does not have any effect on the other one. Look at the probability of passing the practical test. Now this is the question I probably cannot solve. I probably could solve the last question. The last question would be surprised how hard it is. But with this one I can't. It's just, yeah, it's just gone out of my head. But let me show you how I learned how to solve it. So let's draw a tree diagram. And generally, I don't draw tree diagrams for probability problems. Why? Because they're not that complicated necessarily to draw them, but it really helps with this one. So if you want to pass, I'm just going to write pass and fail. I'm going to call it PF and PF. Okay. Passing it, 0.75. So failing it must be 0.25. Passing it, we don't know. That's the thing. That's the key thing about this question. We do not know. We do not know the probability of passing the practical test, which is what we're looking for. So let's call it x. And if that's x, the only other option is to fail. So this is 1 minus x because all probabilities add up to 1. So if 1 is x, the other must be 1 minus x, the rest. And we can do the same logic here. Now, it says here, the probability of passing only one of the two parts is 0.36. So we can either pass the theory and fail the practical, or we can fail the theory and pass the practical. This would give us our option. This would give us our new equation. This would be 0.575 times by failure, which is 1 minus f, plus 0.25x, because we fail when we pass, and because we're going through each one, we multiply. And we know that this is 0.36. Now we can do our completing. This 1 minus x. Simplifying. There you go. That's what I was for. Simplifying. So yeah, we have 0.75 minus 0.75x plus 0.25x equals 0.36. Okay. Next, let's move on to the other side. So we're going to take away the 0.36 and we're going to move this to the right side. Okay. 0.75 minus 0.36 is, sorry, my head, that's 45, 39, yeah. So 0.39 is equal to 0.5x, because this would have resulted in minus 0.5x when you move it to the other side, 0.5x. Now, in order to figure out x, which is the probability of passing the practical test, we just times it by 2. So x equals 0.78, which would be our answer. We can also write 78% if you want. 17. This is clearly hard now because I absolutely hate these questions because they can absolutely throw you apart. Y is directly proportional to the square root of t, and y is 15, t equals 9. T is inversely proportional to the cube of x. Or t equals 8 when x equals 2. Find the formula for y in terms of x. This involves two different equations and you have to combine them and it can be a whole mess. Here's how I approached it after solving quite a couple of these. The key thing is we first do not plug in any numbers. You've probably heard me and you're like, what? That makes no sense. Do not plug in any numbers. It will just confuse the hell out of you, and it definitely confused the hell out of me. Let me show you what I mean. So y is directly proportional to the square root of t. Now, if you use our maths knowledge, y equals kx. So y equals k. Now, there are two k's, so I'll just call this k1. This is to signify the first k. The second k from the second equation will be k2. So y equals k and then square root of t. That's key. Do not just say t because you just see t. Make sure you read the whole thing. It's the square root of t. So just the square root of t. Then we have t is inversely proportional. So this is k2 over the cube of x. The cube of x is x cubed. So now notice we can plug in t immediately. So y equals k. Oh, no. K1 times by the square root of k2 over x cubed. Okay. So you're probably thinking, oh, what does this mean? Well, let's just put these all together. So y is equal to, and then we have the top fraction here. We have k1 times by the square root of k2. And then at the bottom, we also have the square root of x cubed. Okay, and now notice we have our equation here. This one you want to get it to. You want to combine both equations and simplify until you get to a point like this, depending on whatever numbers you have. Now this is why I said do not plug in any numbers. You might be tempted to, and you might be thinking, okay, this will give me a couple marks, and that is true. But if you want to solve this question, I would recommend not to, and just try to do some basic algebraic manipulation. Now, because we've done this, we can just figure out the values of K1 and K2 really easily, and you get our answer just like that. So let's do that. Let's do the first equation over here. Y is equal to K1 times by, let's plug in the numbers as well, good idea. 15 is equal to K1 times by the square root of 9. 15 equals K1 times 3. So K1 is equal to 5. Okay. Let's plug that in here. So K1 is 5. Let's also figure out K2 before we do that. T, so 8, is equal to K2 over 2 cubed. So K2 would be 8 times 8. So K2 is equal to 64. Now you can plug these in. Y is equal to 5 times the square root of 64 over the square root of x cubed. Complete mess, but whatever. Which is equal to 8 times 5 over the square root of x cubed. So y is equal to 40 over the square root of x cubed, and that will be your answer. Okay. Hopefully you understand this. Do not plug in the numbers first, because if you do, you'll get a complete mess. And the numbers represent K1 and K2. But if you combine them and do all of this stuff, you'll forget what they mean, and that is where I got stuck. Okay, but now I've learned if you just call them K1 and K2, you'll remember what they mean, and you'll remember what you're actually looking for. The K's do not matter, they're constants. You can find them, but the X and the Y is what truly matters. Okay, hope you understand that question. Question number 18. Work out the value of 5/4 of 9 minus the power of minus half times 4 2/3 over 2 to the power minus 3. Holy. Let's first simplify the numerator. It's a good start. And this question is how many marks? 4 marks, okay. This, let's first put these as improper fractions. I think that's a bit easier to understand. So 45 plus 4, 49 over 9, times by 14 over 3. Great, and this is the power minus half. Minus means you have to flip the fraction, so let's rewrite that again. So we're not doing massive steps each time, we're just doing slow parts that will eventually break the question down into a thing we can find the answer for easily. So let's write these out again, and this will be 9 14/9 times by 14 over 3. 2 to minus 3, and this is the power of half. Now, fractional power means you have to do like the root, the square root, cube root, fourth root, fifth, whatever, depending on the denominator. So 2 means the square root, if we had 3, cube root, 4, fourth root, and so on. So let's do that now. So we have 3/7 because we have to square root both parts, times by 14 over 3 to 2 minus 3. When you multiply these fractions together, these 3 will cancel out, so both these 3 will cancel out. And this 7 will cancel out times 1, and this will be 2. So in the end, we'd get 2, and then 2 minus 3. If you do not understand this part, this is just multiplication. You can, there's not a trick to this. You can literally multiply the numbers out, and you'll realize they will cancel out to just 2, because you get 42 over 21, which is 2. Now we can do this. So this is technically to the power of 1. And whenever we have this division, this means you minus. So we have 2, 1 minus 3, which is equal to 2 to the 4th, and that's equal to 16. A quick note about powers of 2. I remember 2 to the power 5 all the time because it's like a landmark to me if it's 32, so I don't have to do all this multiplication every time you get lost. I always know 2 to the power 5 is 32. Might help you. It's just a very niche tip if you're going for high grades. Anyways, 19, solve this question. This is definitely higher round now. This is just long, okay? This is not necessarily difficult. It is just long, and you can get caught out if you make the wrong move. So I'm in the exam, and immediately I'm seeing these these algebraic fractions here, and I see that this is the form they want to give it to me, and I can tell this is going to make a quadratic because I've seen these questions before, and I can tell I'm going to have to plug in the quadratic formula. So immediately I have a good sense of what I need to do, okay? with some questions, it's a good idea to realize, okay, I need to do this. Okay, I can see it's directing me this way. If you see a bunch of triangles, it's probably Pythagoras, trigonometry, or something along the lines of that. You're not gonna use circle theorems when you see a triangle. You have a good guidance of where this is gonna go. So let's do this. When we're adding, we have to make the denominators the same. So let's times each fraction by the other denominator. So this would be x minus 1 over 2x minus 1 plus 3 2x minus 1. Sorry, I should times this by. I should times this by x minus 1 as well. Over x minus 1 and then 2x minus 1. This will give it the same denominator. So what do we get? I'm going to keep these as the bracket form, but here is what we get. So this would be, at the top we'd have x minus 1 plus 6x minus 3 over 2x minus 1, x minus 1. Now, next what I'm going to do is I'm first going to also simplify this. So we'd get 7x minus 4 over 2x minus 1. And now I'm going to times both of these brackets by, I'm going to move these to the other side by just timesing them. So we get 7x minus 4. And because it's just one, it's just the same brackets, And now this should be solvable by now. So I'm going to keep this right side clear for the quadratic formula. This is equal to, and then if I quickly expand this, we get 2x squared, and then minus 2x minus x plus 1, 7x minus 4 is equal to 2x squared minus 3x plus 1. Let's check the 7x and add the 4 inverse to get the one side to be equal to 0. So then we get 2x squared minus 10x plus 5 equals 0. Now let's plug in the quadratic formula, because if you try to factor this, it's just going to be wrong. Look at the answer, yeah. Unless you have to manipulate that, no. This is clearly quadratic formula, and it's definitely a good guess to try to do that. So let's start solving. So x is equal to the square root of minus, this line's crazy. Minus b, which will just be minus 10, which is just 10, plus or minus the square root of minus 10 squared, which is 100, minus 4 times a, which is 2, times c, which is 5, bam, over 2 times a, which is 2, and you get x equals 10 plus or minus, let's simplify the root, we get 100, minus 4 times 2 times 5, which is 4 times 5 times 2, which is 40, so we get square root of 60, over 4, which is equal to 10 plus or minus square root of 60, that's equal to square root of 4 times 15, square root of 4 is 2. Oh, okay. 2 root 15 over 4. And that's equal to 5 plus or minus root 15 over 2, which is our answer. Okay, look at this. Okay, some people may have forgotten to simplify. Please look at the form they want you to give to it. They want you to give it to it. Because even if it's like the correct answer, it might be a different form. And people may forget that, and that's gonna kick you up. Okay, look at the form they want you to give it in, and make it that. Okay, there was another question about a triangle and a square, really complicated, and it was about a specific form. Even though the ratio was technically correct, it was not in the correct form. Make it the correct form, please. The center of a circle is the point with coordinates -1, 3. And the point A with coordinates 6, 8 lies on the circle. Find an equation of the tangent to the circle at A. Give your answer in the form ax plus by plus c. Once again, you have a form question. Do not just write y equals mx plus c in that form, because that will be wrong. Okay, let's go. Technically, in the exam, I would be starting to think about the equation and everything. Ignore that. Please, please, please ignore that. Okay, if you just want the straight answer, if you want the answer here, just ignore that. We see a tangent of the circle. Find an equation of the tangent of the circle at A. So we don't really care about the center and the whole equation. And also, if it was the center, this would be an incredibly hard question for GCSE. So I just want to point that out. So don't panic if you see this. N is the tangent. What do we know about the tangent? Let's go through our circle theorems. One of our circle theorems says the tangent is the radius at 90 degrees. So it should be like a circle, and this would be like a radius, whatever. It means at 90 degrees. What does this mean? Well, we also know that two lines, if they meet at 90 degrees, they are perpendicular to each other. So figure out the equation of the equation of the line of the radius, or the line diameter that goes through a circle, whatever. We can then figure out the gradient of the tangent, and then from there figure out the rest of the equation. I'm going to solve this GCSE style, and I'm not going to use the different form that AS level uses, but it's, if you do learn that, it's not that complicated, but it makes life so much easier. Doesn't matter. First, let's figure out the gradient of the radius of the circle to that point. Okay, because perpendicular is, I'll show you, it's just times minus 1 and flip. So m is equal to 8 minus, oh no, it's 3, over 6 minus 1. Always put the brackets because it might throw you off, and if you get it wrong here, the whole question's gone. From getting 4 marks, obviously. 5/7. Okay. What this means is the tangent gradient must be minus 7/5. So the tangent gradient equals minus 7/5. Now you can show this to the examiner, saying minus 7/5 times by 5/7 equals minus 1, and perpendicular lines, when you have perpendicular lines, their gradient should multiply to minus 1. So you could also just put 5/7 and then go from there. However, if you just learn to just flip the fraction, so if you flip the fraction, we get 7/5, and then chuck a minus, you're good. Now we need to figure out the rest of the equation. So y is equal to minus 7/5 of x plus c. Let's plug in the point we know is on that line, which is 6,8. 8 is equal to minus 7/5 of 6 plus c. So what do we do next? I here would multiply by 5. So 40 is equal to minus 42 plus c, 5c. We get 82 equals 5c. So c equals 82 over 5. I was just rearranging and simplifying there. Hopefully you can see how that equation comes to life, or how to get the c. Now we can write this out in the form y equals minus 7/5 of x plus 82 over 5. And we want to get it into the form ax plus by plus c equals 0. Remember, read the form. Technically, this is correct, like I said with the previous question. This is the correct form. Nothing wrong with it. However, the question wants you to format it differently. So let's put in that form. First, I'm going to times everything by 5 to get 5y is equal to minus 7/5. Oh, no, just minus 7x because we've done by 5 plus 82. That's 28. 82. Notice here that a, b, and c are integers, so I can't just move them there. I have to make them all integers, and I can do that by timesing by 5. Now let's move everything to the left side to get the form 7x plus 5y minus 82 equals 0. Final question. This is definitely a very hard question. 3 circles, each a radius 4 centimeters. The centers of the circles A, B, and C are such that ABC is a straight line, and AB equals BC equals 4 centimeters. Work out the total area of the two shaded regions. This is by far the hardest GCSE questions, and a hardest GCSE question, and I want to show you how to do it. So I'm not going to tell you the answer straight away. I'm going to show you what I might be thinking during the exam, and how I might naturally lead to the answer. Because this question, in addition to being long, it's also one of them that requires that intuition, that little eureka moment where you're like, okay, that's the little trick that helps me solve it, you know? And I'm going to show you, because if I just tell you it, you're not going to have like a pathway to getting similar questions like this correct again. Instead, you're just going to know the answer for this question, and other questions may throw you off. So here we go. So in the exam, I see these circles touching. I might just instantly label these 4. Okay, 4, 4. That's what I've done. Next, I see you want the shaded region. Okay. So somehow I need to figure out like these maybe these white parts and subtract it from the area of that circle. That might work. Yeah, that might work. So how can I figure out the area of these whole parts? That's a bit. Well, see now I'll be struggling. Hmm. Well, I mean we have sectors here. Apologize for these industrial lines. We have sectors here. Yeah, I guess that can work. Here is the thing that I would argue kind of makes it like click. Notice that from this center B to this center is also 4 centimeters because it's radius, and this is 4, this is 4, and 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 this is 4. They're all the same side, which means it's equilateral. So this is 60, this is 60, and so on. Okay. Why did barely anyone see this? Well, it's because you had to work with multiple circles. I think that's what might have held people back. People had to work with multiple circles and they had to see the relations between these circles, okay? Because if you just look at one circle, of course it's going to be hard to find like one part of it but if you look at another circle, you're like, oh, I know that part, that's just a chord, okay? This not only tests you on sectors and areas, this also tests you on chords. This combines everything. And I think the intuition gap for this question was people not being able to, not smoothly, but to be able to realize that if you looked amongst multiple circles and combined what they could provide, you could easily get your answer, okay? And it's also noticing some basic like triangle stuff, okay? One thing, when you have these hard geometry problems, I always tell people is please, please, please break it down into a smaller shape. Whatever you do, smaller shapes, break it down. It will help you so much, and we've just made it to triangles. I think we all know what triangles are, especially if you're trying to solve question 21, and especially if you're trying to go for grain and with this problem. So let's continue. So I'm going to want to find this thing, if that makes sense, this kind of shape. This, like, if I draw it on here, I want to find like this little shape here. And if I have 4 of these, I can just retract it from the area. So this is equal to one of these sectors. So sector plus chord. Let's start going ahead and solving this. Like I said, it's a long question. Sector plus chord. Okay, let's find this sector. So this would be, it would be 60 over 360 times by pi times by r squared, which is 4 squared, and that's equal to 1/6 times by 16 pi. Okay, I am going to skip some parts here. Of course, if you're trying to find this question and you're grade 5, 6, or maybe even 7, kind of no point of solving this. A, this is barely, the question of this difficulty will barely come up, and B, it's just too hard. Okay, I would say for an average GCSE student, it is too hard. Okay, if you're trying to go for 8 and 9s, please keep watching, and if you are 8 and 9, then you should be able to understand these shortcuts as well. But if you're lower grades and you want to see how this is done and it might help you solve other ones, then by all means, please keep watching it, no problem. But this is incredibly hard. Okay, that's the sector. Let's figure out the chord. I'm going to simplify this actually, which is equal to 8. There you go. So the chord is equal to, so in this case, it would be the whole sector minus the area of the triangle. So it'd be, so we know the sector area is 8 over 3 pi, because they're all the same circle, minus the area of the triangle, which is 1/2 times sin 60 times by 4 squared, because it's either side, yeah. It's 8 over 3 pi is equal to 8 because 64 is going to be 16 times a half would be 8 times sin 60. Now sin 60 is 3 over 2 because, yeah, it's a cost that it would be half. So 8k, this would be 4 and that would be 1. 8 over 3 pi minus 4√3. Okay. Okay. Now we need to add these up together. So if we add this, so then total is equal to 16 over 3 pi minus 4 root 3. Okay, I'm saying this is correct. If this is wrong, I do apologize. 16 over 3, because you add that, so that would just be 16 over 3, yeah, okay. And then you times this by 4, minus it from 16, okay. So then you'd have the area, which is 4 pi, is 4 squared pi, 4 squared pi minus 4 lots of whatever this is. This is crazy at this point. And you get 16 pi minus 64 root 3 plus 16 root 3. Okay. And then if you make this even more here, we'd get, if you make this a 3, it'd be 48 pi over 3 minus 64 pi. Oh, this should be pi, sorry. Pi over 3, and then I'm put 16 root 3. This is a question. And then if you simplify this further, you get minus 16. Yep, this is correct. 16 root 3 or minus 16 pi over 3 is your answer. Honestly, big question. No need for all of this. But they put in GCSE anyways, it's fine. So I think the key things from this question was to look at don't look at each circle individually, but look at them together and see how you can like work with them multiple at the same time, you know. Another one is to break the shape down into smaller shapes. I think if you just drew those triangles and said they were all 60 and all 4 centimeters, oh, easy question, and you'll get it, okay? But you know, if you didn't show them that is the intuition gap, I think the thing that would lead you to most people being able to solve this question would be those triangles. If you didn't show the triangles, this is a much harder question and probably like an Olympiad level question, but don't worry, GCSE, you can do it. Thank you for watching, guys. This was the whole paper. So if I just zoom out, that was the whole paper done. Every question is correct, and in the graph ones, I do apologize, but I did give you the range they'd accept. So yeah, thank you for watching, and have a good day.